Okay, right, so question 11. We're talking about the graph of y equals f of x, and let's just underline that. So when it's talking about f of x, it's just talking about the graph here, the line. Okay, so it says write down the coordinates of the turning point of the graph. So where does f of x turn around? Well, you can see the gradient here is negative. It's heading downwards. So negative, 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 turns around here and then becomes positive. So the turning point is going to be the coordinates of that point there. So it's along the corridor to 1 and then down the stairs to -3. So if you had to write down the coordinates, you're going to put 1 and then -3. Alright, that's the turning point, that red dot. Part B, write down the estimate for the roots of f of x. When does f of x, when does this graph equal 0? Alright, so it's not talking about when does the x values equal 0, it's talking about when does the graph cross the line y equals 0. Alright, you can see, look, the y from our original equation here has changed to a 0 to make this one here. When does y equal 0? When does the graph cross the line y equals 0, I should say. So let's go to the y-axis. So y is 6 here, 5, 4, 3, 2, 1. Y is 0 here, alright, and the y-axis, sorry, when the line y equals 0 is this line here, alright, spreads out. I'm trying to do this as neatly as I can. So search along this line until you see the graph crossing it. Well, we're going all the way up here, and the graph crosses that line right there. Okay, and also if we go searching this way, it crosses the line here. So what are the values, what are the x values when this happens, when this intersection occurs? So you've got 2, and that's 2.5 there, 2.6, 2.7, it's somewhere in between 2.7 and 2.8. So I'm going to write down 2.75. Okay, I think that's probably enough accuracy. And then going the other way, you've got minus 0.5, 0.6, 0.7. So it's between minus 0.7 and 0.8. I mean, you can have a look a bit closer just to give you an idea of what I'm talking about. The graph is in between, that's minus 0.7 there, and that's minus 0.8. So it's minus 0.75 really. So let's write that down. So we've got two results, 2.75 and minus 0.75. I'm using a new pen. Bit tricky, just getting used to it now. So excuse the handwriting. And the part C, use the graph to find an estimate for, it says f1.5. So the function, this is like, look what's happened here. The x here has changed to 1.5. So what we're saying is when x is 1.5, then what is the output? What the y value when x is 1.5? X has changed to 1.5. So if you go to the x-axis this time, this is the x-axis here. Alright, so we're looking for 1.5. There's 1.5. And we need to read off the graph. I'll try and do this as neat as I can. So we're reading down to the graph, because it's below that point. And we're trying to find out what is the value here. So we know x is 1.5. What's the y value? If we read across, what's the y value going to be? So I'm getting something around here. And looking at the scale, slightly different scale, isn't it? You have to be careful with that. The scale is a bit different on the y-axis. So one big square is a whole number, is 1. So breaking this up, so this is going up, it's 5 squares, going up in 2s. Minus 2.2, minus 2.4. Let me zoom in. You're going to see this a lot clearer, I think, if I give you a bit of a zoom in. So we're down here, minus 2.2, minus 2.4, minus 2.6, minus 2.8. I think that's, no, hold on a second, what am I talking about? So yes, that is right. Minus 2.8. We're reading from that dot there, weren't we? 1.5 down and across to minus 2.8. Okay, so let's write that down before I forget. Minus 2.8. Alright, would be the answer for that one. I hope that makes sense, and I hope that was some use. and I'll see you in the next video.